All right, we are going to make the notes for 11-4, volume of prisms and cylinders. Um, First of all, volume is space inside a figure. Okay, ooh, my writing is horrible here. Um, and this will be in units cubed. Volume, this is in particular for prisms and cylinders. And if you'll recall, there are pyramids and cones, but this is only for prisms and cylinders. The difference being a prism will have two congruent and parallel bases. So that one is a rectangular prism there. Or a cylinder is basically a prism, but the bases are circles. But again, there are two of them. The next day we will hit pyramids, which come to a point, and cones. But this is for prisms. The volume of a prism is fairly simple. It is going to be base area times the height. So I'm going to not just put B, I'm going to put BA for base area, and you're going to have to calculate the base area and then times it by the height. I mentioned you have to figure out the base area. If it's an octagon, figure out that base area. If it's a pentagon, figure out that base area. It's not just one number. So depending on what type of figure the base is, you've got to calculate it, multiply by the height. The volume of a cylinder, now it's essentially the same thing, base area times height, but a cylinder we already know is a circle. And we know the formula for circle is pi r squared times the height. Okay, so a cylinder will always hit p pi r squared because we're dealing strictly with circled bases. So let's try number 1 here. Find the volume of this triangle prism. Again, they tell you that this is a triangle prism. Do not look at this picture and say, okay, the base is a square, because there needs to be two parallel and congruent bases to be considered a square prism there. There is no base up above that matches this yellow base on the bottom. So in actuality, the base is actually a triangle. This prism kind of got flopped on its side. There's a triangle here in yellow, and then there's a triangle that's congruent and equal in the background. So keep that in mind. Not all prisms are always on the ground. This one just got flopped over. So this going front to back like this is actually the height. Okay, so the volume formula is now pretty straightforward. It's base area times height. We are dealing with a triangle, so let's figure out the area of that triangle. The triangle formula is 1/2 base times height. You just look at this triangle by itself. This is 10, this is 6, that's 90 degrees. And then multiply it by the three-dimensional height, which actually we have this number already. It is 5 going front to back here. That's 5. So running out of room, the volume is 1/2 6 times 10 times the three-dimensional height of 5. Okay, I'm going to erase all this nonsense here. And all of this will equal 150 meters cubed, which means there are 150 of these three-dimensional cubes that would fit inside here. I'm going to just try to draw one, but it's basically little boxes that fit inside that figure. Okay, now we've got number 2 here. Figure out the volume of this cylinder. It says find it in the volume in terms of pi, and also find it to the nearest tenth. So they want you to do it kind of twice, 2 different answers here. Again, the base is a circle. The formula is, because we know the base is a circle, the formula for a base area of a circle is pi r squared times the three-dimensional height. So the volume here, the radius is 4. So it's pi 4 squared times height of 16. This is 256 pi meters cubed. That's in terms of pi. I left the pi symbol there. Or if I go to the calculator, multiply 256 times pi, you'll get 803.8 meters cubed. That's in terms to the nearest tenth. Okay, and we'll finish this up with number 3 here. Find the volume of the composite figure here. Basically, it's this backwards looking L. Don't look for a particular formula that has the formula for an L. You're going to need to break this into more familiar faces. I'm going to draw a line this way, and draw a line this way. And I'm going to figure out the volume of the top box here, and then figure out the volume of the bottom kind of more rectangular box. Now this one, the numbers almost don't match the picture itself. This looks like a 2 by 2 by 2 box, but it is 2. This is 2 here, but this is only 1 going left to right. So it's not a perfect 2 by 2 by 2. There is a more rectangular guy here. That's 2 up and down, 4 this way, and then 1 left to right. Okay, so you just figure out the volume of one of these guys, and then volume of this, and then just add this up. This is base area. The base is a 2 by 1, so it is 2 times 1 times the height of, whoops, this is also, I need this height, that's 2. So that looks like that is a volume of 4 cubic inches. This one here is a base of 4 by 1 rectangle on the bottom, 4 times 1, and a height of 2, and that is 8. And then we just add it together, and the whole composite is 12 inches cubed. Okay, so you got to split it into more familiar figures.